So welcome back, and here this is the next quantum circuit, and 3 qubit states are there. I'm taking the decimal notation 1 2 4. Now I'm taking the operations from left to right. So here head mode operation is there, h of 0 comma 4, and add 1 1 comma 5. Next you have to add the remaining 2 comma 6 and 3 comma 7. Next after that we have C naught, that is x 2 to 1, so that's why 2 comma 3, and you have to add the remaining, that is a 4. If you add 4, 6 comma 7. And the next we have x, that is 0 comma 2, add 1 1 comma 3. Next you have to add 4 4 comma 6 5 comma 7. Next we have z on 1, that's why it is 0 comma 1. Next add 2 2 comma 3. Next add 4 4 comma 5 6 comma 7. Whenever you are adding that a decimal state number, you have to add all the previous operations. Okay, and after that we have again C naught, but this time it is from 1 to 4, so that's why 1 comma 5, and the remaining is 2, that's why sorry, this is 3 comma 7. You have to add 2, that's it. And fine. So once you got all these things, now take the initial state. I told you one small technique: whenever head mod operation is there, better to take these first numbers in that bracket, off on off on. So this is off on like this. For x it is not required, it's just a flip. Okay, so I'm taking the initial state as 0 1 2 3. So first a head mod. So here it is a 0 plus 4, 1 plus 5, 2 plus 6, 3 plus 7. I'm not taking any normalization constant. And after that we have 2 x gates at a time, you can apply, no issue. So I'm writing 2 x gates there, only x gate. And now first is 0. Here there is no 0, here 0, 0 to 2, that's why it will become 2. Next 4, here there is no 4. So but here 4 to 6, that's why it is 6. Next 1, in the first here we don't have any 1, so that's why just go to the next one, 1 2 3 3 5, here no 5. Next 5 to 7. Next 2 2 to 3, here 3 to 1. Careful, you have to see both the things. So here 2 to 3 and again 3 to 1, so that's why we have 1 here. Next 6 6 to 7, 7 to 5. Next 3 3 to 2, 2 to 0. Next 7 7 to 6, 6 to 4. And after that J, which gives some phase change to on state, and off state no change. Here 2 off as it is, 6 off. Next 3 on, minus 3, 7 on, minus 7, 1 on, minus 1, 5 on. Next 0 off, 4 off. And finally there is one more x gate which flip 1 to 5, 5 to 1, and 3 to 7, 7 to 3. So 2 6 no change, minus 7 minus 3, minus 5 minus 1, because 1 and 5 flipped, and 0 plus 4. So 2 states are there in that combination, that's why I'm taking the normalization constant as 1 by root 2. Right. So next if you want to write the other states, that is the next column 4 5 6 7, remember you need not to do anything, just change the middle sign. This is the advantage whenever you are dealing with this head mode operations. And finally I can write directly, that is a 2 minus 6 minus 7 plus 3, minus 5 plus 1, and 0 minus 4. Normalization constant is as usual. So if you want, you please check and check whether you are getting this answer or not. Please check. Okay. And after that you can implement you can take this circuit in the simulator and check what is the output. Right. So this is the next gate, next circuit. Okay. So here also we have 3 qubits, 1, 2, 4. Let me write the operations starting with the head mart on 4, H0 comma 4, H1 comma 5. Next you have to add 2, 2 comma 6, H 3 comma 7. Yes. Sorry. Yeah, it's fine. Now one more head mod is there, so that's why on 1, that's why h of 0 comma 1. So this is nothing but you have to add 2, 2 comma 3. Next add 4, 4 comma 5, and 6 comma 7. So the 2 head mods over, and after that if you observe carefully here, see here we have C0 and here we have Y. Now you got a doubt, which one we have to write first, Y or that above C0? See, here there is no connection between 2 and 1 states. That means I am talking about this 2 and 1 states. That's why you can write Y either before that C0 operations or after C0 operations, no issue. But if you observe carefully, here there is a one C0, that's why you can't bring this Y this side. Okay, but you can write this Y either before this C0 operations or after C0 operations, you can write anything. So no issue. Now I am taking X, that is a 4 to 2, 4 comma 6, and you have to add 1, that is a 5 comma 7. Next one more X, that is a 2 to 4 this time, so 2 comma 6, and you have to add 1, a 3 comma 7. Next you can take Y, that is a 0 comma 1, Y 2 comma 3. Next Y you have to add 4, 4 comma 5, Y 6 comma 7. Next we have this is C0 operation, and here also you can take here this H either before this C0 or after C0, any no issue, because there is no connection between 2 and 4. That's why you can write. So now I am taking C0 again, that is 2 to 3 and 6 to 7, and finally we have head mod. Let me take this here, and final head mod is on 4. The first one is repeated, 1 comma 5, 2 comma 6, and 3 comma 7. Fine. So everything is ready. Now we have to start the start with initial state, that is a 0 1 2 3. Now first head mod operation is there, so all are off. That's why 0 plus 4, 1 plus 5, 2 plus 6, 3 plus 7. Normalization constant I am not taking now. And next one more head mod, so 0 off, 0 plus 1, I hope you already understand, off on like this, right? So plus 4, that is a 4 plus 5. Next one on, 0 minus 1, and this is a 4 minus 5. Next to 2 plus 6, 2 is a 2 plus 3, and 6 plus 7. 3, that is a 2 minus 3, and plus 6 minus 7, right? And after that we have X operations. I am taking this combined X together. Okay, no need to apply separately. I am taking 2X. So 0, here there is no 0, no 1, and 2 3 is there, 4 5 6 7 is there. So 0, 1 as it is, 4 to 6, 6 to 2, 5 to 7, 7 to 3. I hope you are observing. Please see this one. Please see that operations. Next to 0 as it is. Next plus. No need to do it again because earlier above step 4 plus 5 you have written 2 plus 3. Now 4 minus 5, that's why 2 minus 3 I am directly writing. Next to 2. Here there is no 2 but second 2 you have 2 to 6, that's it. 6 plus 3, here there is no 3 but here 3, 6 plus 7. Next here 6 is there, 6 to 4, here there is no 4. Next 7, 7 to 5, that's it. The next one is easy to write because 6 minus 7, just change the sign. Change the sign. Earlier it is 6 plus 7 become 4 plus 5. Now 6 minus 7 4 minus 5 I am writing. Next y. So here off state you will get I and on you will get minus I. Flip with some phase change, right? Okay, right. So proceed. 0. This is I 0. Sorry, it should be flip. I'm sorry. That is 1 minus a 0. I hope you understand. Plus I again. I think everywhere I is there. So that's why what I'm writing is I'm writing outside I. Right. Now, so 0 flip 1 minus 0 because minus I will be there. I have written I written outside. Plus 2 become 3, 3 become minus 2. I already outside. Next 0, same 1 plus 0 plus 2, sorry. Whatever you have written earlier, just change the sign in the middle because 2 become 3, 3 become minus 2, that's why minus of minus plus. Next is 6. 6 becomes 7, 7 become minus 6, 4 to 5, 5 to minus 4 because I is common. Next here just change the sign in the middle, no need to worry, that's it, easy. And after that we have one more x gate is there, so little bit lengthy, right? So here x, that is a 2 to 3, 6 to 7, this one I'm doing that. So 1 minus a 0 plus 2 minus 3, again 2 and 3 flip and 6 and 7 flip, 1 plus 0 plus 2 plus 3. Next 6 and 7 flip, that's why 6 minus 7 plus 5 minus 4 no change, 6 plus 7 plus 5 plus 4 no change. Next again we have to apply Hadamard. So here there is no combination of 1 0 2, I think nothing, you have to apply again. So here we have to finally apply this Hadamard operation, right? So I'm not taking any normalization constant. So 1 is nothing but 1 plus 5 minus 0, 0 plus 4 plus 2, 2 is a 2 plus 6, easy, minus 3, 3 is nothing but 3 plus 7. Next we have to take 1, the same above, just change the sign. I think now you understand what I'm saying. This is 1 again, that is a 1 plus 5, so plus 0 plus 4 plus 2 plus 6 plus, earlier minus is there but here now plus is there, like this. Next one 6, 6 become 2 minus 6 minus 7, 3 minus 7 plus 5, 1 minus 5 minus 4, 0 minus 4. Next one directly you can write, this is 2 minus 6, earlier minus now plus, okay, and here as it is and here plus as it is, 1 minus 5, earlier minus, now it is plus, that's why plus 0 minus 4. That's it. And normalization constant 1, 2, 3, 4, 8 states are there, 1 over root 8. It's not surprising. 3 Hadmarks are there, 1 over root 2, 1 over root 2, 1 over root 2. So you got 1 over root 8. And next, if you want to get this 4, 5, 6, 7, if this is the initial state, then what is the final state? You need not to do it again. This is the advantage. And here this sign will change, this one will change, this one will change, here change will come, here change, here. So this part, just take, if plus is there take minus, if minus is there take plus. So here you will get minus, sorry, so here you will get minus, and this is plus, minus, 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 plus, minus, minus. So that yellow color is for this. Right, the rest of the things are the same. And I think I forgot this I outside, I'm sorry. So this is I outside. Okay, now you can write the unitary matrix for this also. Okay, right. So here this is our next quantum circuit, and here also we have 3 qubit states. That's why I'm taking the decimal notation 1, 2, 4. Okay, start from left to right. Start with Hadamard, 0 comma 1, add 2, 2 comma 3. Next you have to add 4 to the all the earlier operations, 4 comma 5, 6 comma 7. Next S, that is 2 to 1, that's why 2 comma 3. Add 4, 6 comma 7. X, 4 comma 6, 5 comma 7. S dagger 2 comma 3, S dagger 6 comma 7. X 4 comma 6, again 5 comma 7. This is a little bit quite interesting. No need to bother about that. These many things are there. Just wait and see. Some magic will be there. And here S 4 comma 5 and S 6 comma 7. And after that H on 1. That's why I repeat. Now carefully observe. So here we have this one. Carefully observe this operation. Whenever you have here X, poly X matrix, and some matrix A, B, C, D, here also I hope I explained this. Whenever you have this situation, this one, this is the right for R, right side R for rows. So it will interchange rows. And this X from left side, so column, let us say column. Automatically one is a right side means other one is a just row is other one is a column. So this will interchange columns. Then what will happen? Then the diagonal elements will interchange. If you want you can check. So this is a B and C. This one possibility. Of course here we are not using that. Okay, just to keep it aside. This one we are not using this, leave it. And here what you are using, please observe. Here X 4 6 and here X 4 6 and here X 5 7, here X 5 7. But you don't have here S dagger 4 6, S dagger 5 7 combination. If it is there, then you can multiply like that, interchange the diagonal elements. But it's not like that. Then what is the technique here? Very simple. Now first observe this one, very important. Please observe this one, 4 6 and 4 6. That means what? from right side 4 6, left side 4 6. That means fourth row and sixth row interchange, fourth column, sixth column interchange. That's why this 6 number is cancelled and it will become 4. Oh, fine. No need to multiply. Yes, no need to multiply. Next, observe, still not understanding. So here we have 5 7, 5 7. So from right side, fifth row, seventh row interchange. From left side operation column, fifth column, seventh column interchange. Then in this matrix, that the 7 is replaced with the 5. Okay. Then this total operation, that means this gone now. This operation's gone, already over. The remaining is, here we have s of 2 comma 3, here you have s of 6 comma 7, and s dagger 2 comma 3 already there. Now s dagger 4 comma 5 it become, because of that x matrix x operation. One more time, you have x and operator and x is there. This x will interchange the rows and this x will interchange the columns. So this is the advantage. And after that we have s of 4 comma 5 and s of 6 comma 7. Now please focus on this. Now here this is s 2 comma 3 and this is s dagger 2 comma 3. That's why cancel I 2 comma 3. Next one, here s dagger 4 comma 5, here s of 4 comma 5, cancel. And finally we left with here s that is s square 6 comma 7. Nice. Finally this entire operations from here to here, that is equivalent to s square 6 7. That means it will affect only 6 and 7 states. That too, if it is 6, no change, because S is a diagonal matrix. I hope you know S square is nothing but Z. 1 0 0 minus 1. So 7th state, I mean if it is 7, you will get minus 1. Fine. Now let us proceed with the head mod operation. So I am taking that first elements 0 2 4 6, because it is easy to write the next one. I am taking head mod 0 plus 1, 2 plus 3, 4 plus 5, 6 plus 7. Now you need not to operate all these things directly, you can. In this method, this is the one of the advantage, cancellations will be there. Okay, so I hope you are following this method. Okay, if you are facing any difficulty, please let me know. And yeah, so only s square operation. So 0 plus 1 no change, 2 plus 3, 4 plus 5, 6 also no change, but 7 minus 7. That's it. And finally again one more head mod is there. Now this is also simple, and here we have head mod operation. Say 0 plus 1 combination, 0 plus 1. For example, if you have 0 and head mod is operated, this head mod operation is operated, what you will write? 0 plus 1. Now here 0 plus 1 is there, that's why write 0. Next 2 plus 3, write 2. 4 plus 5, write 4, because off state. And here 6 minus 7 is there, 6 minus 7, that's why on, which one is on? 7 is on. That's it. And after that, if you want to write for the another unit input, 1 3 5 7, you need not to do all these things, directly come here, just write this, change the sign, 0 minus 1, 2 minus 3, 4 minus 5, 6 plus 7. Now you are applying a head mod on this. Okay, so 0 minus 1, on, which one is on? 1. 2 minus 3, on, 3. 4 minus 5, on, 5. 6 plus 7, off, 6. That's it. Okay, so I hope you are following this, and if you want you can check with this simulator. Okay, right. Right. So the next one, here also we have 3 qubits. So let me represent the decimal notation 1, 2, 4. So first let me write the operations. Here I am writing. So first I am starting with the head mod, that is on 2, 0 comma 2, and add 1, 1 comma 3. Next you have to add 4, 4 comma 6, and 5 comma 7. Next x, it is on 4, 0, 4, 1, 5, 2, 6, 3, 7. Next C naught, 2 to 1, that's why 2 comma 3, add 4, 6 comma 7. Next again C naught, this time 4 to 1, 4 comma 5. I hope you are following. 6 comma 7. Next again C naught, this time 2 to 4, 2 comma 6, add 1, 3 comma 7. Next T, some phase gate is there on 4, add 1, next add 2. Whenever you are adding, you have to add that number to all the previous operations. Don't forget this. Okay, now this is also quite interesting. Now see here, please observe here x operations. See x 6 comma 7, x 6 comma 7, that cancel because x square identity. Whenever you are doing like this, that numbers must be same. For example, you have 6 comma 7 and 6 comma 5, you can't cancel, right? And next, anything else, check. So you got one doubt. So here we have 2 comma 6, here we have 2 comma 6, shall we multiply and cancel? No. See, whenever you want to cancel this, be careful. X of 2 comma 6, x of 2 comma 6, that means you are bringing that x of 2 comma 6 this side, but in middle you should not have any 2, you should not have any 4, then you can multiply. But unfortunately here we have 2, that's why you can't bring it, so leave it. Then what? Okay, so then apply the earlier technique, x from right side, x from left side. See, this is 2 comma 6, this is 2 comma 6. Okay, so 2 comma 6 can come this side. The reason is it is a 4 5, that is 2 comma 6, no common number. So now here 2 becomes 6 and 6 become 2, like that. That's why here whatever you have 2, that is replaced with 6. I hope you understand what I am saying. So that become x of 6 comma 3. Next, still not understanding, here x of 3 comma 7, here x of 3 comma 7. So from right side, third row, seventh row interchange. From left side, third column, seventh column interchange. That's why finally 3 is replaced with 7. Oh, finally again I got here x of 6 comma 7. Fine. So here I left with x of 6 comma 7. Next, anything else? Please check. This gone, 2 comma 6, everything is gone. Next, remaining x of 0 comma 4, x of 1 comma 5, next x of 6 comma 7. Now you got a doubt, why you have written 6 comma 7 this side? Because there is no 6 and 7, na? That's why I can bring this side, no issue. Or you can keep it here, and here this is x of 4 comma 5. Okay, now you got it out. Why you didn't bring that 4 comma 5 here? Why you are not writing here? Because here 4 is there, I can't bring it. But earlier you have written 6 comma 7 this side, because there is a no 6 and a no 7 number, that's why I can write commute, just like a commute, something like that. Okay, that's it, and this is the final x operations, and this side head mod as usual. Okay, and a t as usual. Now let us take the initial state 0 1 4 5, because if I take the first elements easy, this is 0 plus 2, 1 plus 3, 4 plus 6, 5 plus 7. Okay, next normalization constant I will write later. 0 become 4. You have to complete the operation. Okay, right, start with 0. 0 become 4, 4 become 5, that's why it's a finally 5. Next to 2, there is no 2, no change. 1, 1 to 5, 5 to 4. 3, no change. 4, 4 to 0. 6, 6 to 7. Next 5, 5 to 1. 7, 7 to 6. That's it. And after that T operations. Okay, so off on 5 on. So I hope you remember that the T, let me write the T matrix here, the matrix corresponding to T gate, the phase difference pi by 4 for on state, and no change for the off state. 5, so e raised to I pi by 4 I am writing ket plus 2 off state. Next 4, e raised to I pi by 4, I can't take out common, 3 off. Next 0 off, 7 on. Next 1 off, 6 on. That's it. And normalization constant 1 over root 2, because the two states are there. Next, if you want to get the other states, that is 2, 3, 6, 7, apply our technique, no need to do anything, directly come here. Okay, easy. Here minus, here change minus, here this middle sign. So e raised to I pi by 4, 5 minus 2, and this is e raised to I pi by 4, 4 minus 3. Okay, so this is a 0 minus e raised to I pi by 4, 7. Or you can write here plus or minus like this. Plus is for these states and minus is for these states. Okay. So here this is the next quantum circuit, and 3 qubits 1, 2, 4. Let me write the operations. Okay, so this is a h of uh, yeah, 0 comma 4, and add 1, next add 2, next z 0 comma 2, 1 comma 3, 4 comma 6, 5 comma 7. Next we have C naught. Here wait a minute. Now what I am doing here, here we have a C naught combination is there. Okay, this one. Now carefully see. So why I am able to shift that y that side? Yes, there is no connection actually. Here there is no connection between these two. So that's why you can shift that y that to that end. Okay. Now one more time. So this one I am taking this first, and y just moving that side, right side. Okay. So here x combination, that is 4 comma 5, 6 comma 7. Next single x gate, that is 0 comma 1, 2 comma 3, 4 comma 5, 6 comma 7. Next C naught, that is a 1 3, 5 7. Now you can take y, that is on 4. So 1 comma 5 adding 1, next adding 2, that's it. Okay. Now you can operate all these x operations at a time, but please check, is there any cancellations? No, here it's not like that. One thing is there, yes, I think if you observe carefully here 6 7, oh, not one thing, two things are there. X, sorry, see here, x 6 7, x 6 7 side by side, cancel. Next x 4 5, x 4 5 side by side, cancel. That's nice. Okay, now let us take 0 1 2 3. So first a head mod, I'm not taking any normalization constant. Earlier problem, if I am not taken, I request, yeah, I have taken already. Okay, so this is a 0 plus 4, 1 plus 5, 2 plus 6, 3 plus 7. Next we have Z. This is off and on, 0 off, 4 off, 1 off, 5 also. 2 minus 2, 6 minus 6, 3 minus 3, 7 minus 7. Next we have x operation. I am considering the total x operation at a time. 0, 0 to 1, 1 to 3. 4, no 4. 1, 1 to 0. 5, 5 to 7, please observe. 2, 2 to 3, 3 to 1, that's why minus 1. 6, no 6. 3, 3 to 2, that's it. 7 minus 5. Okay, so please check. Right, absolutely right. And after that we have y. So here it is I, here it is minus I. That's why I'm taking I common. Okay, so it flip 3, 3 flip to 7, and sorry, yeah, 1 minute, yeah. So 3 is off, so flip to 7, and 4 on, minus 0, because minus I is there, I already written outside. So 0, 0 to 4, I already written outside. 7 off state, minus 3. Okay, right. 1, okay, minus 5 flip. 6 minus of minus plus, flip to 2, minus 2 flip to 6. 5 on state, that's why plus 1. That's it. Okay, so the normalization constant is root 2, 1 over root 2. And if you want to write for 4 5 6 7, this is the advantage whenever we have head mod gate in the beginning, in the starting. So this is the advantage, no need to do all these things. And come here, I by root 2, just change the middle sign. Minus 5, minus 2, minus 6, minus 1, like this. Okay, so I hope you are following all these quantum circuits. So this is the next quantum circuit. So I'm leaving this as a exercise to you. If you are interested, please try this. Okay, so I will write the operations. If you have still having any confusion, now see this, starting with h, the 0 comma 4. Whenever starting it is a head mod, it is always having a advantage, because you need not to do the operations again and again. Okay, so h of 1 comma 5, next 2 comma 6, h of 3 comma 7. What I am saying is, you will write operations, I mean you will find the output state only for 0 1 2 3, you won't find for 4 5 6 7. You can write it directly, that is what I am saying. So next control S is there, 2 to 4, 2 comma 6. You have to add 1, that is a 3 comma 7. Next control T, 1 to 4, 1 to 5. You have to add 2, 3 comma 7. Now head mod 0 comma 2, 1 comma 3, 4 comma 6, 5 comma 7. 0 comma 1, and next add 2, next add 4 to all the states, next swap, that is 1 comma 4, but remember you have to add the remaining qubit state, that is a 2, so swap 3 comma sorry 3 comma 6, it swap finally 1 to 4 and 4 to 1 and 3 to 6, 6 to 3. So I have written the operations and I request you please start like this 0 1 2 3, and I hope you remember S gate, that is a 100I, and T, that is a 100 e raised to I pi by 4. Okay, so try to do it carefully, and if you are facing any trouble please contact. Okay, I will write the final answer, then you will get some small, I mean some you will get some confidence. I will write the final answer. So here I have given the final output. I request you please check, don't bother about this, okay, so that we can write it as e power I 3 pi by 4. Maybe once you have taken this circuit in the simulator, you will get a phase difference of 3 pi by 4, that means 135, something like that. Okay, so right, I request you please check. And the next one, if you want to take 4 5 6, that is by 4 by 5 by 6 by 7, then you have to simply change the signs. I hope you know that. Okay, right, thank you. So this is also easy, you can do it. 1 2 oh, okay, no problem. So 4 qubit states are there, but no issue, you can do it. So here I am taking the first head mode operation, so that is H 08, no need to get tension, that is a 1 comma 9, you have to add 1, next adding 2. Whenever you are adding, you have to add all the previous states. Okay, so now you have to add 4, that is 4 comma 12, 5 comma 13, 6 comma 14, 7 comma 15. Right, next after that we have X. So the advantage taking that head mod operation first, if you find 0 1 2 3 4 5 6 7, you need not to write again, you simply change the negative sign, I mean negative and positive signs. X gate, that is a 4 comma 5, okay, and after that adding 2, 6 comma 7, now adding 8, that is 12 comma 13, 14 comma 15. Next we have anything you can take, either X or this control Z, anything you can take, it's not a problem. I'm taking again X because X is side by side, it's better. So on 1, so adding 2, next adding a 4, next adding 8. That's it. Next control Z, that is 8 and 4, 8 comma 12, adding 1, 9 13, so adding 2, 10 14, adding 2, 11 15, right, and after that S we have 0 8, the same operations, just H is replaced with S. Just I am writing this, but I request you please try. Not at all difficult algebra, okay, so just try. Just instead of finding matrices and multiplying, this is just an alternate way, that's it. Okay, and after that we have control Y, that is a 4 comma 6, adding 1, 5 comma 7, next adding 8, 12, 14, 13, 15, right? Okay, so I request you please try this also, and here I will give you the answer, you please check. So here I have given the final state answer. I think now you can write 8, 9, 10, 11, 12, 13, 14, 15. You can simply change the signs in the middle, that's it. So I request you please check this, and right. So the last two circuits I have given as a homework. Okay, so I request you please try to do it yourself, and if you are facing any trouble, please contact. Okay, so thank you, and we will meet again.